guys, we're going to start chapter 7.4, which is over parallel lines and proportional parts. Let's look at the theorem. It says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides into segments of proportional lengths. So let's use that theorem to do example 1. So in example 1, we are going to write that PS over SR is equal to PT over TQ. Well, we know by substituting in numbers that SR is 2.5, PT is 7.5, and TQ is 3. So if we cross multiply, we have 3PS is equal to 7.5 times 2.5. Well, 7.5 times 2.5 is 18.75. So if we divide by 3, we get PS is equal to 6.25, and that's our answer. Okay, let's look at this theorem right here. It says if a line intersects two sides of a triangle and separates the sides into proportional corresponding segments, then the line is parallel to the third side of the triangle. And you can see what that is talking about in the diagram to the right. So let's go ahead and look at example 2. So in example 2, we have to show that these two segments, DE and GH, are parallel. So in order to do that, we have to show that DG, so let me write this out, DG over GF is equal to EH over HF. Well, we can start plugging these sides in and see if we get an equal proportion. And if we get an equal proportion, that means they are parallel. So DG is X, because we are not sure what that is. And GF is going to be 3X. And we know this because it says DG is 1/3 the length of GF. And notice there's an imaginary 1 here, so it's like 1 over 3. Well, if we simplify this, the X's are going to cancel out and we get 1/3. Now let's check EH over HF. Well, EH is 3 and HF is 9. 3 divided by 9 simplifies to 1/3. Well, since they are both equal to 1/3, then we know that DE is parallel to GH. And that proves what we were trying to find. Okay, let's look at the next theorem. A mid-segment of a triangle is parallel to one side of the triangle, and its length is 1/2 the length of that side. So you can see what it's talking about in the example. Okay. Let's go ahead and look at example 3. It says, in the figure, XY and XZ are mid-segments of the triangle. Find each measure. Okay? Well, we know that the definition of a mid-segment means that it is half the other segment. So XZ is equal to 1/2 RT. Well, 1/2 RT is 13. So 13 times 1/2 is 6.5. So that's our answer. Same with ST. XY is equal to 1/2 ST. XY is 7, so we need to find ST by multiplying both sides by 2. Because remember, 1/2 and 2 cancel. So that means we have ST is equal to 14. Okay. Lastly, we need to find the measure of angle RYX. Well, we know that RYX is congruent to YXZ. So that means that their measures are also congruent. So the measure of angle YXZ is 124. So that means the measure of angle RYX is also equal to 124. Okay. Now let's look at proportional parts of parallel lines. If 3 or more parallel lines intersect two transversals, then they cut off the transversals proportionally. So it gives you an example. and then you're able to see that illustration off to the right. Okay. Let's look at example 4. It says Megan is drawing a hallway in 1-point perspective. She uses the guidelines shown to draw 2 windows on the left wall. If segments AD, BC, WZ, and XY are all parallel, AB is equal to 8, DC is equal to 9, and ZY is equal to 5. Find WX. So, by one of the corollaries or the theorems that we just read, it says if all of these segments are parallel, then we can write this as a proportion. So AB over WX is equal to DC over ZY. Okay, now let's plug everything in. So AB is 8, WX we don't know, DC is 9, and ZY is 5. So if we cross multiply, we have 8 times 5 is equal to 9WX. Well, that's 40 equal to 9WX. So if we divide by 9, that means WX is equal to 4.4. Because 40 divided by 9 is 4.4. Okay, let's look at the next corollary. If 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. And you can see that off to the right. Okay, let's look at example 5, which I believe is the last example. So in example 5, we need to find X and Y. Okay. Since JM is parallel to KP, which is parallel to LQ, and MP is congruent to PQ, so I know that just by looking at my diagram, then JK is congruent to KL. So that means JK is equal to KL. So JK is equal to KL. K is equal to KL. Well, JK is 6x minus 5, and KL is 4x plus 3. So now let's just solve for x. So I'm going to subtract 4x, and I get 2x minus 5 is equal to 3. Add 5, and I get 2x is equal to 8. Divide by 2, I get x is equal to 4. There's my first value, x. Okay? We're going to use that same definition, and now we're going to say that MP is equal to PQ. Well, MP is 3y plus 8, and PQ is 5y minus 7. This was pretty easy just to put together. Even if we did not know these theorems, we know that we have to set the x's together to get an x value, and we have to set the y's together to get a y value. So let's solve for y here. So I'm going to subtract 5y, and I get negative 2y plus 8 equals negative 7. Subtract negative 8, and I get negative 2y equals negative 15. Divide by negative 2, and I get y is equal to 7.5. Okay? So this concludes these notes.